going live. Okay, good morning, everybody. My name is Kyle Denny, and I'm a planetarium educator here at the Peoria Riverfront Museum, and I am joined with my co-workers and friend, planetarium educator Nick Ray and planetarium director Renee Kerrigan. So today's launch is Perseverance. This is NASA's latest attempt to send a rover to Mars. This is an incredibly exciting mission that is occurring today, and I'm very excited to be able to. We're very excited to be able to share this with you guys. So we are at about T-minus 18 minutes and 55 seconds until launch. Today's launch will be done on board the United Launch Alliance Atlas V rocket. This is one of their biggest variants of the Atlas V rocket. It is the Atlas V 541. So that just means it has a 5-meter fairing, or a payload sort of shroud that's on top of the vehicle. It has 4 solid rocket motors, and it has a single liquid rocket engine on the second stage of the rocket. So the Atlas V rocket is powered by a bunch of different engines. There are 4 solid rocket boosters on the side, as I mentioned. The center stage, or the main liquid engine in the bottom, is called the RD-180 engine, and it generates about 1 million pounds of thrust. And then the second stage is called the Centaur rocket. So the RD-180 is powered by what's called rocket-grade kerosene, which is basically a highly refined version of jet fuel, and the Centaur upper stage is powered by liquid oxygen and liquid hydrogen. It is one of the most efficient upper stages in the world, and that upper stage, on top of the upper stage, will be the Perseverance rover. So I'm going to hand it off at this point to my colleagues to see if they wanted to add anything about the Perseverance mission to Mars. So take it away, guys.
Oh, we're just really excited to see this rover launch to Mars. Perseverance is the upgraded version of the Curiosity rover, which you can see in my virtual background behind me. This is a panorama that the Curiosity rover took of itself while it was on Mars, because it can actually take a selfie by extending out its drill arm and taking pictures with the camera on its arm. So the Curiosity rover has been incredibly successful in its mission to find past water on Mars. And Perseverance will look almost the same. It's got the same body, but it has updated instruments. And in fact, we're going to share a link to where you can zoom in on the rover and check out all the different instruments that are on it in the comments on this live feed. So it's got upgraded cameras, upgraded drilling capabilities, sort of just upgraded scientific instruments, but launching on a successful platform that has been launched before. So hopefully that means we'll have a smooth landing, smooth driving on Mars. They've also upgraded the wheels on Perseverance, because the Curiosity rover, how long has it been up there, Nick, now?
Since 2012, almost eight years, on the anniversary in a couple weeks, I think.
So it's been up there for 8 years, and it's got holes in the wheels. As it's driving on Mars, some of the rocks on Mars are embedded in the dirt, stick up just sort of like you're driving over big tacks. So it's got these holes in the wheels of Curiosity. So Perseverance, they've upgraded the wheels. Hopefully that won't be a possible problem. And it's just an exciting mission. We can't wait for it to land, hopefully in February.
Okay, really quickly, somebody said to turn up the audio. I have turned up the audio a little bit, so I'm hoping that's a little better now. So, can anybody listening hear us good?
I'll talk loud.
Yeah. So, anybody watching, comment. If you are watching, comment below and just let us know, A, if you can hear us, and B, if you have any questions you want to hear about the Perseverance mission, please feel free to ask, and we'd be more than happy to answer them. So,
I'll just mention the. Oh, go ahead.
Oh no, yeah. Tell us about the drone, Nick.
Oh, okay, yeah. So one of the awesome new things that Perseverance is taking, that's never been taken to another world is a drone helicopter to try to fly around on Mars. It's really a test mission to see how capable that is, and then future missions might bring that along as a kind of a scout that can fly ahead and survey the area and look for places for future rovers to drive. So this is a test of the capability of flying on Mars. It's hard to fly on Mars because there's very little atmosphere. It's like 0.5% of what we have on Earth, so very little air. It helps that there's less gravity though, and the helicopter itself is only 4 pounds, and that's on Earth. So it'll weigh even less on Mars, about a third of that, and it'll be spinning blades around really fast. It'll be making short test flights of up to 3 minutes at a time, I believe. And while it's flying around, it'll be using cameras to take pictures from above. The Perseverance rover will be taking video of the drone as it's flying around on Mars. It'll be really sci-fi looking, something we've never seen before. It'll be awesome. Hopefully it all works out.
I can't wait to see those pictures from the helicopter itself, which pretty much only has cameras on it. Is that right, Nick?
Yeah. I don't know what else is on it besides cameras.
And then from the rover taking pictures of the helicopter, it's going to be a new exciting thing, a new exciting way to explore Mars. And then if it's successful, of course, future missions will be able to get around Mars better, because even the rovers that have been successful on Mars, they've really only driven a very short distance. I think Opportunity, which was on Mars for 12 years driving around, I think it went just over a marathon, just over 26 miles. And Curiosity hasn't gone that far yet. So if we could fly on Mars, we'd be able to go to different sites faster and explore a little bit more of the red planet.
Okay, very cool. Thank you guys so much for sharing that exciting information. So we are at T-minus 12 minutes and 44 seconds until the launch of the Perseverance rover on board the Atlas V to Mars. And what I'm going to do now is I'm going to give you guys a very brief rundown of what you're going to see today during today's launch. So obviously at T-minus 0 seconds, you will see the RD-180 engine on the Atlas V ignite, and then the Atlas V at liftoff generates with the solid rocket boosters, and the RD-180 engine generates over 2 million pounds of thrust. So that's an incredible amount of thrust. And because of that, it will reach the speed of sound incredibly fast. It will reach the speed of sound at about 35 seconds after launch. After that, the rocket will undergo what's called max Q, or maximum area of dynamic pressure on the vehicle. At that point, the Atlas V engine will begin to throttle down to be able to protect the vehicle from aerodynamic loads. At about 1 minute and 50 seconds, the solid rocket boosters will burn out and they will be jettisoned to be able to preserve mass now that they're no longer needed. At T plus, 3 minutes and 27 seconds, the payload fairing will jettison, and that's that shroud that I talked about earlier that covers the Perseverance rover from our atmosphere during launch. At 4 minutes and 22 seconds, the RD-180 engine on the Atlas V will cut out as the first stage of the rocket is completely out of fuel, and then the second stage, the smaller second stage on top, will take over. So that will be followed shortly after by 4 minutes and 28 seconds. Will be followed by stage separation. 4 minutes and 38 seconds. We will also see the ignition of the Centaur upper stage and that RL-10 engine powered by liquid oxygen and liquid hydrogen. That will continue up until about 11 minutes and 30 seconds, where you'll have Centaur cutoff, and then the Atlas V will enter a coast period. So that coast period will last for about 30 minutes until T plus 45 minutes into today's mission, where the engine will reignite, and that will change Perseverance's current orbit from a circular orbit about the Earth to what's called a hyperbolic orbit. A hyperbolic orbit just simply means Perseverance will be leaving Earth's gravitational influence and out into what's called a solar orbit. It will be an elliptical solar orbit that will intercept Mars in February 2021. That's just sort of a really, really brief rundown of today's mission. It's extremely exciting to see. I can tell you, I've personally seen these rockets go up and it is a very exciting experience to see. So super excited. I know Renee and Nick are too. So this is such an incredibly historic day for NASA to be able to do this, because in addition to this launch sending Perseverance to Mars as well as Ingenuity, it is also a milestone. It is a sort of a foundation for NASA's next Mars mission, which is called the Mars Sample Return Mission, and that will return actual sort of samples taken by the Perseverance rover on Mars. Perseverance will leave those samples on Mars, and then it will be sent back to Earth on board the Mars Sample Return Mission. That will be later this decade. So very exciting.
And we didn't really talk about the sample taking that Perseverance will do. This is kind of bonkers, in my opinion. It's really ambitious by NASA. So Perseverance is going to, on its arm, which we put a link to the rover in the comments below this feed, so you can check out all the instruments on it. But it's got this arm that's covered in scientific instruments and a drill, so that it can analyze the rocks on Mars, which is one of the whole reasons it's there, so that we can look for past signs of water and also astrobiology. So with Perseverance, NASA is expressly looking for past signs of life on Mars, which is pretty exciting. If Mars was once covered with water, if it was once a lot more like Earth, then maybe it once had some form of life, and probably just microbial life, really small little life forms, if it existed at all. There's a tremendous amount of evidence that Mars was once covered in water, but we don't yet have solid evidence that Mars once had life on it. And so that's one of the things that Perseverance is looking for. So with this sample return that Kyle was mentioning, it could drill into the surface of Mars, just 2 inches about, and take a sample of the soil or the rock and leave it in these little vials, and it's just going to leave them on the surface of Mars, with the idea that a future mission will be able to collect them and somehow get them away from Mars' surface and atmosphere and back to Earth. Which,
stop laughing.
It's never been done before, and it's really ambitious. And the reason Nick told me to stop laughing is because it's a little funny to imagine these vials of material just being sort of scattered on the surface of Mars. I'm sure that NASA has a plan, and they're not going to just leave them lying around, that they're going to know where they're going to be. But it is very ambitious. So hopefully it'll all work well, and we'll get the first sample returned from Mars, because the only bits of Mars that we have on Earth are meteorites that have been impacted off of the Mars and then made their way down to Earth. Is that right? There's no other pieces of Mars down here.
That's right. Yeah. And we only know that because of the missions that have gone to Mars, and there's sampled the atmosphere of Mars, and some of those meteorites have pockets of Martian atmosphere inside of them, and we could match them up and deduce they're from Mars.
Nick, what are some other exciting parts of this mission that I might not have mentioned? What are you excited about?
Well, first of all, they already have the landing down to like the minute. It's around 2 o'clock in the afternoon Central Time on February 18th, and they know they're going to be landing either on top of or right next to sediment from an ancient river delta. They're going to this crater about 30 miles across. It had a river going into it. It had a river going out of it. This is more than 3.5 billion years ago, when it would have been filled with water. But as that river went into it, it dropped sediment. And it's an obvious river delta, just like you see the Mississippi River Delta, the Nile River Delta. So they're going to be landing either on that or right next to it and climbing up of it, on top of it. And and also cool stuff, unique stuff besides the helicopter. They're going to have microphones. They tried to send microphones before, but it was on the one mission that NASA failed to land. They're 8 for 9 landing on Mars. The one failure had a microphone on it, but they're going to have 2 microphones, one that'll listen as it descends through the atmosphere, and they'll be making a movie as they descend through the atmosphere. So we'll have video and sound. It'll be awesome. And they'll also have a microphone to listen to the invisible infrared lasers that'll vaporize the rocks. We've got ultraviolet lasers to study the rocks up close and find out what the minerals are. all sorts of cool science gadgets.
Okay, so just a quick update on the launch. We are just past 5 minutes and counting. The launch director and mission director have concurred, so they've sort of met to decide whether or not they're go for launch, and they have agreed that they are go to enter the terminal countdown. So the Mars 2020 spacecraft has just entered internal power in preparation for launch, so it is off its ground power and it's now being powered off its own batteries ahead of today's launch. So we are getting very, very close to launched, and this is extremely exciting. 4 minutes and counting, launching here at 6:50 a.m. Central Daylight Time. My heart's definitely starting to go up a little bit here.
How does your heart rate compare to when you watched Curiosity launch in person?
Oh, that was a different beast altogether. So yeah, what Nick's talking about is I'm actually a Floridian, and I have visited Cape Canaveral very many times, and I've seen quite a few rocket launches, and my heart rate was through the roof. My heart rate's always through the roof of a rocket launch, especially a big one. I was at the Demonstration 2 mission with Bob and Doug took off at Kennedy Space Center, and my heart rate was basically through the roof at that point. So we're not quite to that point yet, but I'm smiling because I'm extremely excited. So
I'll admit that I'll be more nervous for the landing. So Nick talked about the crazy landing that these rovers do. It's called 7 minutes of terror because they're really big. They're like the size of a small car or maybe like a golf cart. These Curiosity and Perseverance, and so for them to be able to land safely on Mars, they're sort of suspended. It's called the sky crane. They're suspended from these am I thinking of parachutes, and descending through Mars's atmosphere. But Mars's atmosphere is so thin that they can't just use the parachutes. So then they also use these retro rocket thrusters to slow down their descent, and then gently just place the rover on the surface of Mars. And you can watch a whole video of Curiosity's descent with audio that Nick was mentioning Perseverance will do as well. And I don't have the link for that ready, but I'll make sure to look that up and put that in the comments of this feed as well if you're interested, because it's pretty awesome. The fact that they're having audio on this mission, I'm excited about, because it's just another sense that we'll get to experience. We already have fantastically high resolution images of Mars from these rovers, but now we'll also have a little bit of audio, so we'll be able to imagine we're looking at the surface of Mars and listening to what the wind and other audio experiences sound like.
Okay. That's the other cool thing. It'll have 3D eyes, 3D pictures.
Nice.
It'll be great.
Okay, guys, we are getting extremely close to launch here. We're about 90 seconds away. So at this point, what we're going to do is we're going to tone down our voices and let NASA TV take over here to be able to enjoy the final few minutes of this countdown. So
1 minute 20.
Okay.
OCU armed. SCS count started.
1 minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Vent valves locked.
1 minute.
Rock, report range status.
Range green.
Forty seconds.
Stable at step 3.
28 seconds.
ECS reduced for launch. Roger.
25 seconds.
Status check. Go Atlas. Go Centaur. Go Mars 2020.
Eight, 7, 5, 0.
Release.
RD-180 ignition and liftoff of the Atlas V rocket with the Perseverance rover to Mars. So the vehicle has cleared the tower and is now pitching over
And Atlas PU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good.
So we're now entering the area of maximum
And Mach 1, Atlas 5 is now supersonic.
It has gone past the speed of sound at Mach 1. Those solid rocket
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly.
Those solid rocket motors have about done their job, and they will begin to run out of propellant.
And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
Coming up on that jettison. There they go. The 4 solid rocket motors have jettisoned.
And we have good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance.
Now the Atlas 5 is being powered
Vehicle
by
body rates are responding nominally at this time.
That will continue for another 3 minutes or so. Generating close to about 1 million pounds of thrust at this time.
And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour.
So we're already moving at a speed
And the
of
Centaur reaction
6,000
control
miles per
system is
hour.
now pressurizing to flight levels.
Beautiful shots from
Cape
Cape
winds,
Canaveral.
Denver winds, MetNet.
And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
There goes the payload fairings. That
Denver ones, this is
We have
Cape
good
Winds on the
indication of
MetNet.
payload fairing jettison and
Cape
Centaur
Winds, we'd like to
forward load
request
reactor deck
we
jettison.
take and processed LR6 and LR7 to max altitude.
They make it
And
look
you
so
may
easy.
And the
Right.
RD-180 is
LR8
throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation.
So the first stage of the vehicle has about done its job. It is throttling
Copy
down.
that.
Standing by for BECO shortly.
Coming up on BECO, or booster engine cutoff. You will see the first stage fly away and the second stage of the engine ignite. Looks like we have
And we have
lost the
BECO,
camera.
booster engine cutoff. Standing by for stage separation.
There's a view of the RL-10 engine on the second stage. There you go. You got a perfect, beautiful stage separation. Coming up on RL-10
And we have
ignition.
good indication of Atlas Centaur separation.
There it goes.
And we have MES-1. RL-10 operating parameters look good.
You can
Chamber
see the engine
pressures are
steering
stable.
to get itself on the proper trajectory, which is super cool. This engine is powered by liquid oxygen and liquid hydrogen. It is a
This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
it is a cryogenic engine. That burn will continue for another couple minutes or so. That will put the Perseverance rover into a circular parking orbit about the Earth, about 250 kilometers above the Earth's atmosphere. Super exciting. So we are now on the second stage of the Atlas V rocket as Perseverance continues its journey to Mars.
And we have seen the Centaur PU system go to closed-loop control. Engine response remains nominal, still seeing stable and nominal chamber pressures.
So Kyle, what does that launch feel like when you're there in person?
There's no comparison.
And we are beginning to see the RCS system begin periodic thermal firings to maintain conditions in the loop. And the loop and bottle temperatures are beginning to converge on nominal temperatures.
As the rocket clears the tower, and it's a video never does it justice. If you're ever in Florida, I strongly recommend checking out us.
And initial data review of boost flight
How loud
indicates
is it?
Slightly above nominal performance of the Atlas V booster.
Really close. I've been deafening loud close before, but
how close is that?
3 miles or so. I've been 3
At
miles
this time,
away
the vehicle is 140 miles in altitude, 900 miles downrange, traveling at 14,500 miles per hour.
So the vehicle is traveling at 14,500 miles per hour. A reminder that orbital speed is 17,500 miles per hour, so we are only 3,000 miles per hour away from reaching orbit. You'll probably see the camera cut out occasionally. That is expected as the
And we did see a minor interruption to telemetry there as we switched to a TDRS-compatible data format.
It's switching between
overall telemetry quality is very good.
We're about 433 seconds into flight. The Atlas V is currently in an altitude of 242 kilometers in an orbit inclined 29 degrees to the equator. This burn is the longest burn of today's mission that places the Perseverance rover into that initial parking orbit, because Earth's so big, especially compared to Mars, it takes a lot of energy to be able to put something tiny, tiny relatively speaking. Perseverance is about 1,000 kilograms.
Coming up on 8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
How many Mars launches have you seen? Any others besides Curiosity?
I want to see. I think I saw Opportunity launch, but I think Curiosity is the only one that I was actually at. I was really young when Opportunity went off, so I don't remember any before that. I'm sure I have, I just don't remember them.
Yeah. Yeah, because how many launches have you seen in total?
Hundreds.
Dozens? Hundreds?
Well over 100. So it never gets old.
Yeah.
So we're coming
And
up.
thank you, folks, for your questions and the comments. We'll do our best to answer all of those for you. So if you have any more questions, please feel free to ask them as Perseverance begins this journey towards Mars. And I also like to mention, we talked about the Curiosity rover. Right now, there are 8 active missions at Mars. There's 6 in orbit, 6 spacecrafts orbiting Mars. There's Curiosity on the surface, active, and a stationary lander named InSight, which is active on Mars. And earlier this month, just this July, 2 other countries launched missions to Mars, China and the United Arab Emirates. So if all 3 of these new missions are successful, we will soon have 11 active missions at Mars, which is amazing. We've never had that much exploration happening on a planet before. In fact, there's no other place where we've had multiple
we have seen the PU actuator come off of the LOX-rich stop as expected, and still seeing stable and nominal operating parameters on the RL-10.
Okay, we're coming up at 10 minutes into the flight. We're very close to SECO 1, or single engine cutoff number 1. That'll be the first cutoff of today's mission for the RL-10 engine. The RL-10 engine will ignite once again 30 minutes from now at T plus 45 minutes into flight. And again, that will place
There is approximately
rover
1 minute
from
remaining
a
in the
circular
first
orbit
Centaur
to
burn.
a hyperbolic orbit, a solar orbit that will intercept Mars. So very exciting.
If you enjoy learning about Mars and have enjoyed watching this launch, you might enjoy visiting us in the planetarium. We actually have a whole show about Mars on our current schedule in our Dome Planetarium in Peoria, Illinois. At 4 o'clock every day that we're open, a live show about the exploration of Mars, and you can ask your questions there as well. We also, of course, have shows about what you can see in the night sky and all sorts of other topics and great art
And we've had
exhibits at the
IIT
museum.
vanish.
So
The
if you're
Centaur is
in
now
the
orbital.
Central Illinois area, come
And we've
visit us
had MECO 1.
at the Peoria Riverfront Museum.
Engine cutoff pressure signatures look good. Centaur will coast for approximately 30 minutes prior to the next burn.
We've had single engine cutoff number 1, the Atlas V.
RCS is now commanding 100% settling to settle propellants in the tank.
We have had a successful launch today. Very, very exciting to see this happening.
And
now,
Centaur is now
we have
adjusting its attitude for
orbit.
PTC roll.
We can probably
Body
go ahead
rates
and
and
answer some of you
RCS
guys'
performance look good
questions
at this
that you were
time.
asking. I'm sorry we couldn't get them during the launch because it's a little. My heart was definitely racing a lot there, so it's didn't really get.
I've been answering the questions in the comment feed there, Kyle, but people asked, wanted to know if there was a small helicopter on board. They had heard that, and we responded yes. Ingenuity.
At this time,
small
Centaur
little
is
drone helicopter.
2,400 miles downrange, traveling at 17,300 miles per hour.
Successful future missions will be able to use this technology to explore Mars even better.
And it'll be, I think, a couple months after it lands before they do those test flights. But that'll be awesome next year.
Okay, yeah, so we have a question from Ellen, who asks, when will it land on Mars? And that will be on February 18th, 2021 at Jezero Crater. So very exciting. What else do we have? Eric asks, is it a rover type vehicle? And yes, it is a rover. It is, I think, NASA's 5th rover they have sent to Mars. We had the Sojourner, Spirit, Opportunity, Curiosity, and now Perseverance. So the 5th
And
rover
as we
to go to
pass
Mars.
13 minutes into flight, the
Fun fact,
RCS
all
system
the rovers
temperatures
were
have
named by
converged to
kids
nominal values.
Essay contest.
The Centaur tank
And
pressures
the winner,
remain at stable and
named
expected values.
Perseverance and Ingenuity, the
And,
two winners
still
are at
seeing
the launch in Florida
good
right
overall
now.
performance
Whenever
from
they have the next rover
the
that's going to go
RCS
get the
system.
samples that Perseverance leaves, if you're a kid, remember you can enter that contest to name that rover that's going to retrieve those samples. You can also put your name on the rover. I think we have a link to as well.
NASA's doing a lot of fun things to promote this launch, so and this mission, and I'll put a full list of some of these fun links in this feed. But there is just below this feed on our page where you can make yourself a little selfie on Mars, or a little virtual photo booth. You can put yourself on Mars or right by the rocket. So that's super fun. I know I took a picture of my family at the beach and got a little picture of us sunbathing on Mars using that. One of my coworkers was putting her cats on Mars. So it's a fun thing to play around with. And you can also see what your age would be on Mars. A Mars year is almost 2 Earth years. So if you want to just get instantly younger, take a trip to Mars so you can test your age on Mars, what your weight would be on Mars. Mars is less massive than Earth. It's smaller. So your weight would be different on Mars. So we'll put all those links here in this comment feed, and you can explore some of those fun ways to learn about Mars.
Yeah. So while we're in this coast period, though, if you guys want to, you are more than welcome to ask any questions in the chat about what is going on with today's mission, where we are in today's mission. We've just had the single engine cutoff, or SECO 1, of that upper stage engine, and the Perseverance rover is now what looks to be getting into an orientation ahead of SECO, or engine ignition number 2, that will place the Perseverance rover into a solar orbit. So that is coming up in probably, I think, 20 minutes or so from now. So we've got quite a bit until that actually comes up. Jen says, thank you for hosting this and taking time to answer our questions. You are very welcome, Jen. I'm glad you enjoyed it.
Hey, Kyle, you mentioned earlier how you saw Bob and Doug take off on the SpaceX Dragon. Do you want to mention their return coming up?
Their hopeful return hopefully will happen on Sunday, August 2nd, because there is a hurricane in the area right now, Tropical Storm Isaiah, I think that's how you pronounce it. Could potentially delay that landing, but yes, on August 2nd, it is scheduled that Bob Behnken and Doug Hurley will undock from the International Space Station and return to Earth off the coast of Florida. So that might not happen on Sunday because of the tropical storm I talked about, but this is extremely exciting. They've been up, I think, for over 2 months now, over 64 days, and they will be concluding
passing
their
16
mission.
and a half minutes into flight. Initial review of the MECO 1 orbital parameters indicate that the vehicle trajectory is very close to pre-flight predictions.
Crew Dragon launch. And one of the astronauts who's going up is Bob Behnken's wife, who's also an astronaut and a pilot. Does anyone know the names of the crew members? I think it's 4 people who are going up on that second launch. Is that right?
Yes, I know. So the commander of that mission is Shane Kimbrough. He is a veteran of a space shuttle mission, as well as a previous commander of the International Space Station. Megan MacArthur is Bob Behnken's wife. She will be sharing the same exact seat as Bob did on the Demo 2 mission on board the very same capsule Endeavour. She will be serving as the pilot of that mission. The mission specialist number 1 will be a JAXA astronaut, or a Japanese astronaut, and his name is Akito Hoshide. He will be the International Space Station commander, I believe. He'll be the second Japanese astronaut to command the International Space Station. And then mission specialist 2 is Tomas Pesque. I believe that's how you pronounce his name, but he will be the first European to fly on board the Crew Dragon, and that will be in February of 2021. But that has to be followed up first by not only a successful landing of Demo 2 of Bob and Doug on Sunday, hopefully, but also the Crew 1 mission that will take place in September, and that will be commanded by Michael Hopkins, and the pilot will be Victor Glover. Victor Glover making his first flight.
Passing 18 minutes into flight,
And
the RCS system is now commanding 25% settling. Still seeing nominal operating parameters and temperatures on that system. Also seeing nominal and stable battery voltages and temperatures as well.
We have a little Peoria connection to Mike Hopkins. Mike Hopkins spoke to our summer camp students 3 years ago or so in just a virtual conversation. But in that, we learned that he got married in Peoria, Illinois, right by the museum at Sacred Heart Church, because his wife and her family are from Peoria. So I always am excited when I hear that any astronaut who has a connection to our area will be going to space. It always makes it feel just a little bit more real, a little bit more connected.
And it's really cool because he'll be the commander of the first operational mission of Dragon. So he is the second ever commander of a Dragon. So that's going to be really exciting for him. Somebody with connections to the area.
And I saw that that 3 astronauts will be joining the crew that's going up on the next demo mission for the Dragon from the Soyuz. So will we still be sending astronauts up with the Soyuz for a bit longer? The United States, I mean, or will future launches be from the Dragon and maybe the Boeing vehicle when that is completed?
So yes. So what's going to happen is now that Crew Dragon has become operational, NASA likes having what's called dissimilar redundancy in terms of getting their astronauts into orbit. So my understanding is they will no longer be paying Russia to send our astronauts to orbit, but they will instead sort of be doing a you scratch my back, I scratch your back kind of deal, in that they will be launching some of our astronauts, but we'll be launching some of their cosmonauts. So in the future, Russian cosmonauts will be flying on board the Dragon capsule. So don't know when that's going to start happening, hopefully soon. because international cooperation in space is always a great thing. So, yeah, that will be coming up in probably sometime next year. We'll have Russian cosmonauts on board the Crew Dragon, as well as the Starliner capsule, and that will be the second commercial crew vehicle. They had a bit of a problem back in, what was it, December? They had what was called a mission timing anomaly, which resulted in the first ever Starliner capsule to be placed into an incorrect orbit. So hopefully that doesn't happen again. They're going to refly that test mission later this year, followed by next year the Starliner will launch again with a 3-person crew to visit the space station on their own demonstration mission. So we'll be having multiple crew vehicles visiting the space station instead of just one like there has been with the Soyuz. And before the Soyuz, the space shuttle, obviously.
Now that they got 4 seats on the Dragon, they're going to be increasing the space station crew size from 6 to 7, so they can get a lot more science done. There's more science for them to do up there than they can get done with 6 astronauts up there.
Very true, very true. The more the merrier. So. Alright, so yeah, we're just sort of waiting here, waiting for that next engine start to begin. That won't be for a little while now. So, yeah. So we're just kind of hanging out, chilling, waiting for this engine ignition to take place. Looks like Nick has a special friend with him.
Yes.
Marzi.
Mars. Yeah, there's the polar ice cap.
And appropriate poster in the background for you, Nick.
See Mars. Yeah, we got these in the museum store. Not just Mars, but all the planets. Very cute.
My daughter loves the Pluto and Charon. They magnetize together, and she has a little moon as well. That's one of her favorites. Celestial buddies, they're called.
So I had to make sure to ask my daughter that I could borrow this, because in the past I've just taken it for if we had an event at the museum about Mars or Pluto or something, and then I've been accused of stealing it. So I have her permission.
Good.
Cool.
InSight, the stationary lander on Mars, we didn't mention much about that mission. It's pretty cool. It landed in 2016.
2018. It was supposed to go in 2016. It was supposed to go in 2016. Missed the launch window. And if you miss, you have to wait 2 years and 2 months for the Earth to come around and catch up to Mars again.
As soon as I was saying 2016, I was thinking, that doesn't seem right. It hasn't been up there 4 years now. So it's been up there since 2018. And it's pretty cool because it was designed to study Mars's interior to help us understand the way Mars formed, the way it transformed over time. And so it had this plan to send this, they called it a mole, a hammer basically, or it was really more of a hammer, a small hammer that would hammer itself 15 feet, I believe, was the goal, under Mars's surface, through the surface, so that it could test the temperature below the surface and seismic waves and that sort of thing. But unfortunately, the little hammer didn't quite go down that far. It made its way under the surface of Mars, but not 15 feet. How far did it get, Nick? Do you know?
Useless. It got itself in and no further.
But it did set up, InSight did set up ways to test Mars's seismology. So that has been successful. It's been able to detect some Mars quakes since it's been up on Mars.
Hundreds.
And it can test some other aspects of Mars's atmosphere and climate. And that's interesting because the thing is, about 1 billion, maybe 2 billion years ago, Mars had a thicker atmosphere. It was once covered, a third of it was covered in water. It must have had a magnetic field, a stronger magnetic field at that time, if it had a thicker atmosphere. And so the question is sort of, what happened? How did Mars lose its atmosphere? So it still has an atmosphere, but it's very thin, and lose its water. And if we can understand the evolution of Mars and its climate and geology, it might help us understand Earth a little bit better and help us solve some
passing
problems down
25
here.
minutes
So
into flight,
that's
seeing
part of
another
what
minor
these,
interruption to
suite of
telemetry as
missions
we
at Mars
change
are
over
doing.
Tejas satellites.
That reminds me,
All
some
data
other
at
cool
this time
things
is indicating
Perseverance
nominal
is bringing
performance.
for,
The
to help us
RCS
with
system
eventually
continues
sending
to shuttle
astronauts to
propellants
Mars.
in the tank.
Right now,
Still
NASA's
seeing
focused
stable
on,
Centaur
after the space station, getting
tank
people
pressures
back
as
to
well.
the moon, hopefully at a permanent, semi-permanent basis. And from there, eventually sending the first astronauts to Mars, and hopefully in the 2030s. I think that's what they say.
That's what they say.
On the Perseverance, yeah, the old joke is we're always 20 years away from landing on Mars. Still true today, I guess. But they're bringing an experiment on the Perseverance rover called MOXIE, which is an acronym for something, like all NASA things. And it's going to be taking some of that carbon dioxide out of the Martian atmosphere. Even though the atmosphere of Mars is very, very thin, it's mostly carbon dioxide. They're going to be taking the carbon dioxide and using that machinery to convert it into oxygen, just as a test of the feasibility of doing that. So then, in the eventuality of sending astronauts to Mars someday, have that scaled up to a larger size where you can generate oxygen from the carbon dioxide in the Martian atmosphere. Another cool thing they're taking are sample materials. I think 5 different sample materials for possible spacesuits to use on Mars, and they've got those set up as part of one of the cameras or one of the lasers target areas. They can look at these targets and calibrate the instruments, and so 5 of these targets will be different spacesuit material, and they'll be able to watch how those materials change over time on Mars and see how they're affected by the Martian atmosphere.
That's the great thing about NASA. Those things can be very systematic, right? So even if it seems like we've been talking about getting humans to Mars for so long, at least we have some tests in place to help us to get one step closer to that goal. We're always 20 years away from landing on Mars. It makes me think of, we landed on the moon 51 years ago. Apollo 11 landed on the moon. And at that time, we had such ambition for what we could do. I read a book by Carl Sagan that was written right around that time, and I remember him talking about the first moon base where humans would be living on the moon by 1980, and we'd be at Mars by the year 2000 or before, I think, in that prediction.
I think he was just a tad bit too optimistic there.
Yeah.
Well, and I think the people are confused. General public are confused why that's not true as well. But I think the main difference is during the moon landings, NASA got 5% of the federal budget, and today it's 0.5%. So
yeah,
if they had that funding, then those things probably would have happened.
So right now, the Perseverance rover in the Atlas V upper stage look to be currently passing by just south of Madagascar, so they are flying over the Indian Ocean right now. As a reminder, the orbital velocity that this is traveling at is over 17,500 miles per hour, so it takes 90 minutes to be able to complete one revolution about the Earth, which is incredibly fast. So if that's the coast of Madagascar that we see coming up here, you can just incredibly get a sense of how incredibly quick these things go. It's either Madagascar, actually it might just be Africa. There's nothing on the screen that indicates what landmass we're looking at. That's the really, really cool thing about space that a lot of astronauts notice is that there's no borders. You can't see any sense of borders or anything that looks like a map. So you have to really know your geography quite well. So we still have a while to go until that burn begins. Again, as a reminder, that burn will place the Atlas V. It will accelerate the Atlas V from a parking orbit of about 250 kilometers to a hyperbolic orbit that will be put into a solar orbit around the sun. That solar orbit will hopefully intercept Mars in February 2021. So we still have a little bit till that burn begins. You can see the Atlas V is slowly turning into what's called a prograde attitude. Prograde just simply means moving or pointed directly into the direction of travel. So you want to be pointing a prograde to be able to increase your velocity to be able to leave Earth's orbit, because if you point retrograde or opposite the direction of Earth's travel, you will lose velocity and Earth's gravity will pull you back down. So you want to make sure you're facing forward, or you will burn up and lose your spacecraft. So that maneuver to that attitude is beginning right now, and that will probably be another 15 minutes before that burn begins. So we got plenty of time. In the meantime, we have a couple of people watching. Realize it's pretty early in the morning for a lot of you guys. It's super early for us as well. But if you do have any questions about the mission that you might not be able to ask otherwise, feel free to ask, and we'd be more than happy to answer them. So, some quick orbital mechanics. Fun facts?
I was just going to say, fun fact, just like the Curiosity rover, the Perseverance rover is powered by radioactive plutonium, also just like the time-traveling DeLorean in the first Back to the Future movie.
Yeah. And if I remember correctly from what I heard is that in previous missions, the NASA actually required authorization from the president to be able to launch plutonium on board their rockets. But this is the first actual mission where that's not necessary. The NASA administrator, Jim Bridenstine, is the one that signs off on that now instead of the president. So it's very
plutonium named after Pluto.
Named after Pluto, now dwarf planet Pluto.
Yeah, so these two rovers, both Curiosity and Perseverance, they have enough battery power to be able to last for 14 years on Mars, which is pretty great. The Spirit and Opportunity, the smaller rovers that were on Mars before these two rovers, and Opportunity worked during Curiosity's time on Mars as well. They were powered by solar panels. The missions were designed to last for 6 months originally. I mean, they always give a small window of time in which the mission is planned for, and then if it's successful, it's usually extended. So Curiosity and Spirit and Opportunity supposed to last 6 months, and they thought that maybe their solar panels would be covered by dust, and they wouldn't be able to get enough power to operate anymore. But the wind on Mars blew the dust off the solar panels, and so they lasted for years. Spirit, I remember when it got stuck. It got stuck in the sand on Mars back when I was, I believe, still an intern at Lakeview Museum. So when was that? Back in 2010, maybe 2011. That Spirit got stuck. So that mission ended, but Opportunity lasted all the way until last year?
A few years ago. I don't know. 2015 or something?
Yeah, 2018.
I think 12.
18. Oh, okay.
I think it lasted 12 years on Mars when it was designed to last 6 months. So it's a little rover that could.
Yeah.
Pretty great designed spacecrafts. But the great thing about Curiosity and Perseverance is that they don't have those solar panels, so their battery powers will just give them constant power. It also allows them to be bigger, more robust rovers on the surface of Mars.
Cool.
And Dust did get Opportunity in the end, not on the panels, but a global dust storm that blocked the sun for so long it couldn't charge its batteries and couldn't survive.
Yeah, solar panels are a lightweight alternative to plutonium, but at the same time, having solar panels on a dusty world poses its own set of challenges, clearly. But yeah, Opportunity did land in January 2004, and it ended its mission during that global dust storm that occurred in 2018, in June 2018.
Coming up on 35 minutes into flight,
So we
approximately
10
10 minutes remaining in this coast period of flight. Continuing to see good performance from the RCS system. Good response.
And then what happens after the ignition? Just coasting
that passive thermal
for
control
7 months or so,
direction.
Yeah, essentially, yeah. We'll have the
also
payload
seeing
separate from the
stable
rocket,
Centaur
and
tank
it will
pressures
coast. It'll make
and
periodic
overall
course
excellent
corrections to
performance from the
adjust
telemetry
and fine-tune its
systems.
trajectory before arriving to Mars in February 18, 2021. So that is 8 months from now, 7 months from now, something like that. It's a pretty long journey to Mars, despite Mars being one of the closest planets in the solar system. Interestingly enough, there are actually 2 other missions to Mars that occurred this month. The Tianwen-1 mission that occurred from China. They launched their own rover and lander as well as orbiter to Mars. That was the heaviest payload ever launched to Mars. That occurred a couple days ago. And before that, the Mars Hope mission by the United Arab Emirates launched on board a Japanese rocket. So there are quite a few missions going on to Mars, and the reason for that is a lot of people recognize that we're in what's called a Mars transfer window, and that just occurs every roughly 2 years and 2 months as Earth begins to catch up with Mars. I believe Mars needs to be 45 degrees ahead of the Earth for that window to be open, because this year Mars will be making its closest approach in October. So every 2 years and 2 months there's a window to go to Mars. Conversely, every 2 years and 2 months is a window to come back to Earth if you're at Mars. So a journey to Mars could take over 4 years. So
that's part of what the mission of the astronauts up on the International Space Station is, to help us understand how to keep humans healthy in space for that amount of time. Of course, if you're living in a microgravity or almost no gravity environment, your muscles don't have to work very hard to move around, and your bones lose density. There's weird things that happens with the fluids in your body, like and even your eyes can start to change shape, so people's vision can be affected when they're in space for long periods of time. So part of what the astronauts on the International Space Station do is sort of test all different sorts of things they can do to stay healthy, because if we're going to go to Mars, it's going to, like Kyle said, that'll be a long mission, maybe a 4-year mission, at least a 3-year mission to get to Mars and back.
yeah, it's going to be a huge challenge. Additionally, you also have to bring all your consumables with you, or you have to have them already there when you launch, which is expensive and adds mass and complexity to the mission. So it's quite a challenge to send people to Mars versus sending an unmanned probe like we're seeing today to Mars. That's why it's significantly cheaper to send unmanned probes. But at the same time, as far as a geologic perspective goes, there's no substitute for a set of eyes and a hammer, to quote Harrison Smith from Apollo 17, who was the first geologist, the only geologist to go to the moon in 1972. So
the scientists who study the moon's geology have said that the Apollo missions, one single Apollo mission even, gave us more information about the moon and its formation and its geology than every single robotic mission that we had sent. And that's a reason I think of frequently that it would be fantastic to send humans to Mars. The robots can do great work, and they're built by humans and controlled by humans, and the scientists here on Earth are analyzing all the evidence that they discover. But being able to actually send a geologist to Mars who could make decisions and act on them immediately and follow their own curiosity and instincts while they're up on the surface, there'd be no replacement for the science we'd be able to find from just one single mission. So hopefully someday in our lifetimes, what do you think, guys? Are we going to make it to Mars?
I think it's going to happen in this decade. I think it's going to...
Who do you think is going to be sending people to Mars?
Yeah, I think SpaceX is going to beat NASA. Well, not beat, because it's probably going to be a joint endeavor. But based on what I'm seeing now,
and passing 39 minutes into flight,
probably be
still seeing very good performance from
at least send a Starship,
Centaur main vehicle batteries,
to Mars at some point in this
stable
decade.
voltage
They are
and
currently
temperature.
building that spacecraft.
Also starting to see a little bit of a
it.
response in
They
Centaur body
plan on
rates
launching
as
it hopefully this week.
we start to turn towards the
Have they
NES2
got a test
attitude.
that hasn't blown up recently?
Well, no, but that's how they test.
RCS,
That's how they learn.
RCS performance
They learn
and
from failures,
Centaur
whereas
body rates
NASA,
I'm being
appear nominal. at
I
this
know
time.
that all rockets, when they're testing, have a lot of explosions. It's just pretty impressive to see a Starlink, or not Starlink, Starship blow up. It's a big vehicle,
yeah.
and so those. But of course, I know that all failures teach us something, and so space is hard. Takes a lot of explosions to get a successful launch.
Yes, it does. And SpaceX, that's just how their approach is compared to NASA. NASA is more methodical, whereas they don't want any failures whatsoever during the testing process. Their testing process is primarily done through models and simulations and rigorous subscale testing. SpaceX likes to do all-up testing to see what challenges they run into. They are a entirely different beast how they do missions to Mars and missions to space in general. So they blew up plenty of Falcon rockets when they were first starting up. They blew up all 3 of the first Falcon 1 rockets, and they blew up 2 Falcon 9 rockets, although those were less than ideal because those had customers on board. One was a NASA payload. But they are maturing.
Not people, we should be clear. They didn't have human customers on board. They had payloads on board.
Yeah. They had a Dragon capsule that was carrying unmanned supplies to the space station blow up during launch. That was unfortunate for the space station. That was back in 2015. But SpaceX tests through very rigorous, just like all-up testing. And actually, NASA used to test like that during the Apollo era. The Saturn V was tested quite a bit.
Seeing a good response in Centaur body rates as we spin down from the passive thermal control roll.
One of the great things about NASA working with SpaceX with the Commercial Crew Program is then all of that testing, that isn't that's not on NASA's dime. That's not. They basically have contracted with SpaceX to either deliver supplies to the International Space Station or people, and so they don't have to do the testing. They don't have to pay for the new rockets if something goes wrong.
In approximately 3 minutes, the Centaur engine will ignite to begin the second burn of today's mission. 33 seconds prior to ignition, the RL-10 will begin the fuel and
for example, with
oxidizer pre-start sequence.
SpaceX was delivering supplies
this burn
to the
will last approximately 8
for a long
minutes.
time before they started sending people. And NASA's only real priority for SpaceX was just don't damage the space station. So they could build their capsule however they wanted, as long as it could dock with the space station and as long as it didn't damage the space station. And that took a lot of that pressure off of NASA, put it on SpaceX, but of course then they can use their vehicles for their own purposes as well. So seems like it's working well, this commercial partnership between SpaceX and NASA, and hopefully it will allow for more exploration.
Very true. So we are about 2 minutes.
With Curiosity?
We are about 2 minutes away from the ignition of that RL-10 engine that will accelerate the spacecraft out of Earth's orbit and onto Mars. That burn will last approximately 5 minutes, I believe, and that will be followed by a coast phase for a couple of minutes before separation of Perseverance, which is probably where we'll wrap up the webcast or our live stream today.
No, 7 months. 7 months.
Oh, just do the whole thing for 7 months. There you go. So that burn is coming up very shortly here. You can see on the side of the Atlas rocket, you can see those 2 little jets firing, and those are called reaction control system jets, and those basically control the attitude of the rocket. So what you're seeing right now is those jets firing to be able to put the Atlas into.
And RCS is now commanding 100% settling in preparation for the second burn.
So they are
still seeing nominal temperatures and loop pressures in that system.
Yeah. So those RCS engines are firing away to get ready for that burn. That burn again will last for approximately 5 minutes, and that will deplete the Centaur upper stage of its fuel and put the Perseverance on a trajectory to Mars. So, very exciting. So they're currently, I believe, at an altitude of about 153 kilometers above the Earth, inclined 29 degrees to the either side of the equator. So, that,
why 29 degrees? Is that the latitude at Cape Canaveral, or?
Well, the latitude at Cape Canaveral is 28.6 degrees.
And we have fuel pre-start on the RL-10.
Due east, but that's just because they get the orbit on the plane of Mars, basically. So they are about to burn here any moment now. We'll be seeing that ignition take place. And we have ignition of the RL-10 engine. Or it looks like just about, maybe not quite. Doing something back there. I may have been a little premature. They might be. I think what they're doing is a pre-start of that engine. There it goes. So
And
there's
we
our
have main engine start 2.
So this is the second burn in today's launch of the Centaur engine, and again, that will place the Centaur
The
and
RL-10 pressures look
onto that
stable and
hyperbolic
nominal
orbit
at the
that
beginning
I
of the
was
second
talking
burn.
about. And that will last for approximately 5 minutes or so. And that will change its orbital velocity from 17,500 miles per hour to over, I think, 25,000 miles per hour. So quite a bit faster than the space station. Actually, faster than the Apollo missions were too, because the Apollo missions never technically left Earth's orbit. They were placed into an extremely eccentric Earth orbit that intercepted the plane of the moon.
And the PU system is in closed-loop control as well. It's controlling mass errors to near zero, and seeing good response from the PU actuator.
Apogee rapidly increasing as they increase their orbital velocity. That burn will last a couple more minutes. And this burn needs to be accurate down to the second.
And Centaur body rates and thrust vector controller performance both look very stable at the beginning of the burn.
NASA's pretty good at getting those burns down to the correct time and exact second. I remember hearing that New Horizons, which was flying for 9.5 years to get to Pluto, got to Pluto about 2 seconds early.
Yeah.
And that was not because of the burn of the rockets or anything like that. That was actually because of a little bit of, I believe, solar wind.
Yep. Yeah, once you're in orbit around the sun, there's other things impacting you other than the gravity of like the moon and the Earth and Mars. You have solar pressure from the sun that acts to exert a force that changes very slightly, changes your spacecraft's attitude and orbit. You also have the influence of other planets. If you're flying past Jupiter and Saturn, such as New Horizons, who flew by Jupiter first, that will change your orbit. So there's a lot of things that they have to take into account when going to Mars and beyond to be able to make sure they're on the correct trajectory. And the fact that we're able to do that at all is pretty incredible when you think about it. Because how far away is Pluto again? It's something like 40 times the
3 billion miles?
Yeah, 3 billion miles. It's far, and to be able to get that accurate within 2 seconds is pretty incredible. Like, astoundingly incredible, actually. Just
The New Horizons mission remains one of my very favorite missions that has happened since I've been involved in astronomy education. It was so fun to teach about, getting to see Pluto discovered right before our very eyes as those pictures came back every week from the New
A little under 5 minutes remaining in the burn. The Centaur body rates continue to look stable. Still seeing good performance from the
that was an Atlas V as well.
RL-10 as the operating parameters remain stable and nominal, and still seeing the PU system balance those mass errors to near zero.
Just about a year ago, just over a year ago, and it's still flying through the Kuiper Belt. So hopefully it'll find another object along its path or close enough to its path that it'll be able to observe something else for us once again.
Yeah. So we're still within that burn of the RL-10 engine. If you are just joining us, this is the burn that will place Perseverance onto a trajectory that will take it to Mars. Its apogee has increased to about 10,000 kilometers. Apogee is the highest point in its orbit. That apogee will continue to increase until it basically reaches infinity, at which point it will be considered on what's called a hyperbolic orbit. So we're still a couple of minutes away until that burn concludes. That apogee is rapidly increasing.
The Perseverance spacecraft is in the payload, which is on that little capsule in the front of the spacecraft you see on the image here.
Yeah, it's that little heat shield on top. So that heat shield is what Perseverance needs to be able to survive re-entry into Mars's atmosphere. They call it the 7 minutes of terror because for 7 minutes, Perseverance will first go out of communication with the Earth in February 2021, followed by separation of deployment of the parachutes, followed by deployment of the heat shield, and then the little lander, this little cruise stage that on the bottom of the well, it's not cruise stage, it's basically a rocket engine on the top that's
And
holding
approximately
on to
3 minutes
Perseverance,
remain in
that
this
will slow down
second
that
burn of
descent,
today's mission.
and then we'll actually
Still
lower
seeing
it down
nominal operating
onto
parameters
Mars's
across the board,
surface
including
of Mars's
stable battery
Mars's
temperatures
surface,
and
so that's going to
voltages,
be
and
an
stable
incredibly
Centaur tank
complex
pressures.
series of events to get Perseverance onto the surface of Mars, and that will be in February 2021, the 7 minutes of terror. And they've actually done this once before with the Curiosity system. It's the same exact landing system as the Curiosity rover. Perseverance and Curiosity are way pretty similar. Perseverance is a little heavier, so the methods to get there don't need to be changed much.
And if you're just tuning in, the Perseverance rover, which has just launched from Earth and hopefully is just completing its next burn to get away from Earth orbit, will land on Mars in February of 2021. It'll be looking for signs of past life on the surface of Mars, micro life forms on Mars' surface. Be exploring a river delta, an ancient lake on the surface of Mars. So we hope to learn a lot from this mission. Which will be joining the Curiosity rover and the stationary lander InSight on the surface of Mars, all NASA missions.
And all missions you can follow online. NASA's got a website devoted to their Mars exploration program, and you can click on the Curiosity mission or the InSight mission. Curiosity mission, they have blog updates every couple of days with pictures and what they're doing, the science they're doing, and you can see maps of where it's traveled, climbing up this 3-mile high mountain, and pretty cool to be able to follow along
About 1
in
minute
pretty much
remaining
real
in the
time,
burn.
and you'll be able to
Still
do
seeing
the
nominal
same thing with
RL10
Perseverance
operating parameters
when it gets
and
to Mars in February.
nominal
I
data across
follow
the
these
board.
missions on social media. You can follow them on Facebook, Twitter, Instagram, probably the other forms of social media that I'm too old to be a part of. I'm sure they're on TikTok, I suppose. I don't know. But when you follow the missions on social media, you'll get a new picture right there in your feed. So it's just a nice, easy way to keep track of what's happening in space. And for that matter, you can follow the astronauts who are up on the International Space Station on social media platforms. So it's a really fun way to keep up with what's happening with our space exploration.
All right, coming up on that single engine cutoff number 2, that will happen here.
And we have
momentarily.
MECO
And
2,
we have,
main engine cutoff.
So Perseverance is now on its way to Mars. In
The
just a few minutes
RL10
from
shutdown parameters look
Right.
good.
Perseverance
And
rover
we're
will
seeing-
jettison from the Atlas rocket and will be on.
Sorry,
the
seeing
cruise stage
turn to the
on its
separation
mission to Mars.
attitude. RCS system performance looks good as we do that, and so do Centaur body rates.
They'll be getting a constant signal from that cruise stage the whole trip to Mars, basically, or just like a beeping or telemetry, or
Yes, that'll be done through NASA's Deep Space Network that they have that will be communicating constantly with the rover during its mission to Mars, just to make sure everything is healthy, just make sure the spacecraft's on a proper trajectory, just to make sure all the systems are okay to be able to complete its mission. So that will be
A little
exciting.
under 4 minutes remaining until Mars 2020 separation.
So a little under 4 minutes
Continuing to
remaining
see
until
good
that
performance
separation
from the
begins.
telemetry system, getting all around good data.
So what they're doing right now is just checking.
Also
if the systems
seeing,
are okay.
Nominal battery voltages and temperatures.
So everything looks like it's going extremely well. Today's mission has been an incredible success so far. Obviously, we still have one more milestone to go, and that's that separation of the Perseverance rover from the Atlas V. So hopefully that works out okay. But if that does, then Perseverance is on its way to Mars. So.
And again, if you've joined us a little later, we are teaching about Mars daily in the planetarium with our To Mars and Beyond show, which is showing at 4 o'clock every day that we're open. Right now, every day that we're open means Tuesday through Saturday. And you can come to as many planetarium shows as you'd like with museum admission. We also have shows about the current night sky and what astronomers do. We have special shows just for younger children. earlier in the morning. So there's always something to learn in the planetarium, and we've enjoyed bringing our content to everyone virtually here on our social media platforms, but you can also come and see us at the museum in person. We hope to see you there sometime soon.
We should also mention, of course, we've got measures for the coronavirus. We've got limited seating, spaced out seating in the planetarium. Everybody, staff and visitors, wearing a mask. And
that's right. And we should mention
2
that we'll
minutes
be doing,
remaining until spacecraft
Kyle will be
separation.
doing another live
Still
stream,
seeing
hopefully,
very nominal performance of the RCS
cooperating,
system.
of
It's
the
controlling
full moon
Centaur
this
body rates
weekend.
very well.
Is that right, Kyle?
On August 3rd, so actually on Monday, I believe.
Moon Day.
Moon Day, there you go.
Moon
That's
Day.
it. That'll be the sturgeon moon. The August moon is called the sturgeon moon, after the Native American fish, the largest Native fish in North America.
And seeing an increase in Centaur roll rates as Centaur spins up in preparation for Spacecraft Sep.
So we're just waiting for separation now, is that right?
That's right. So what the Atlas V has done is begun a roll to be able to put the Perseverance rover onto what's called a passive thermal control mode, or PTC, sort of this barbecue roll that will slowly rotate the capsule that way to keep heating from the sun evenly onto the entire spacecraft. So that's what the Atlas V is doing right now. And that will be followed very shortly by state separation. So that is about probably a minute away or so.
A little less than 1 minute remaining until spacecraft separation.
1 minute away, yeah.
That's good, because my family's waking up all around me in my house.
Yeah. Almost done.
And about 30 seconds until spacecraft separation, still seeing stable Centaur tank pressures, very good performance from the RCS system, and stable indications from the avionics systems as well.
Okay, should be about 10 seconds or so from now until that stage separation begins and Perseverance is on its way to Mars finally. After which the Perseverance rover will be powered by its solar
And we have
panels
successful separation of Mars 2020 with the Perseverance rover.
So Perseverance is on its way to Mars. It just heard an extremely loud applause from Mission Control there. So they are on their way to Mars. And that's going to conclude our live stream for the day. Thank you guys so much for joining us. I hope you guys enjoyed this incredibly exciting mission to Mars. Again, my name is Kyle Denny, and I'm joined here with Nick Ray, planetarium educator, and Renee Kerrigan, planetarium director here at the Peoria Riverfront Museum. I hope you guys enjoyed our live stream. Again, thank you guys so much. Especially thank you to our membership.
And with the successful separation of Mars 2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.